Okay, this will be the very last one. So some a very quick recap over the whole lot, right, before we just go into the hardest questions. So when we're looking at volume, we're thinking about an area which we sweep, or pull like an accordion to give us this volume. Okay, prisms have got a shape at one end and the other end, and that's why it works. We take this triangle or a pentagon or a square and we pull it. Okay, we make these prism shapes. Okay, but a cylinder is a circle that we pull. Okay, so we're looking for areas multiplied by lengths or heights, whatever you want to call it. Okay, so we need to remember the equations for area. So for a square, it's just length times the height. For a square, it'll be the same, so that's effectively length squared. For our pentagon, we have to know that you'd be given that area, or it'd be obvious from you split into triangles for you or something. But yeah, you need to know a triangle, a half base times the height, and you need to know your circle pi r squared. Okay, so thinking about those things. Um, I think here was interesting when we had the parallelogram, if you can say it, which is like our rectangle that's been pushed. So we're using the 3 and the 4 to get the area. We're not using this inclined length. I thought that was a really good question to put in. When we come to do our cylinders, don't forget, r squared, not doing r cubed, it's r squared. And we talked a bit about multiplying decimals, how we ignored the decimal place and added it in at the end. Again, that's quite important. The pyramids and cones, we're doing the exact same thing as what we're doing for the prisms and the cylinders, except we third it. Simple as that, we third it. Okay. And then we saw sphere. We've got a equation given to us, 4/3 pi r cubed. It's cubed, not squared like for a circle. So don't forget that. Okay. So I thought that was all quite straightforward. We're looking at hemispheres. Don't forget to half it, obviously. But this was probably the most interesting bit when we started to put these shapes together. Okay, so just making sure we're using the the um, the right strategy. Write down your strategy, keep your equations separate, make it clear to the marker what you're doing. Okay, and this was a great question as well. This is really making you think. Wait a minute, I only know the radius of this sphere is 3. What's the radius of a circle? Well, they're the same. They share the same circle, don't they? The base of that sphere is the end of the cylinder. So the sphere and the cylinder have both got radius 3. It's a great question. Okay. And for this, you could do it two ways. You could have said pi r squared of the big circle, take away pi r squared of the small circle, and then times that by the height. Or you could say pi r squared times by the height for the big circle, and then take away pi r squared times the height of the smaller circle cylinder, so you can do the big cylinder, take away small cylinder, or do big circle, take away small circle, times by the height. Okay, very, very good. I like those. Okay. In here, I've actually, these are old exam questions. I can't see that, although I do recognise it. I might have just skimmed too fast. But calculator, non-calculator papers, 2019, 18, 17, 16, 15. So question 8 in 2019, 7, 6, 7. So the calculator paper is around about question 7. There's usually a volume question. So I've actually got those videos already on, so you can have a look at them if you want. And there's a non-calc one, which I think you should look at as well. Gets you thinking about, putting your fractions together and multiplying the decimals. All right. So that kind of takes care of this page, okay? But again, just to kind of quickly go over it, you're thinking about a strategy. Okay, so for this one, you should be thinking, well, wait a minute, what two shapes have I got? Well, that's half a sphere, it's a hemisphere. So I know I'm going to have 4/3 pi r cubed divided by 2. And this is my cone. So I'm going to have pi r squared h, which would be a cylinder, and that's going to be a third of that because it's a cone or a pyramid. Okay? And then you're just, technical difficulties. Time's gone crazy. And then you're just looking to sub in. Okay, so what's the radius of this hemisphere? Well, diameter is 12, so the radius is going to be 6. Nice and straightforward. Pi r squared h for the cone. Well, they share the same base, so the radius is the same. Radius is 6. What's the height though? The height of the whole thing is 17. Is the height of the cone 17? No. If you were to look at that from the side, you would see your cone and you'd see the hemisphere. So if the whole thing is 17, yeah, your hemisphere, the radius of the hemisphere is 6. That means the kind of height of the hemisphere is 6, isn't it? Which would make this 11. Okay, so again, they're making you work for that just a little bit. Okay, making you put the right h in. Okay, but start off that way. Think, what two shapes have I got? What's their equations? What do I know? Just take your time. Okay. This one again, we'd just be doing the big cone, take away this little cone. Okay. What's the equation for our cone? It's not that anyway. Pi r squared h a third. Okay, pi r squared h is a cylinder, and we're doing a third because it's a cone. Okay, so we want to do that for the big one, take away the same for the small one. Okay, simple. So what's the radius of the big one? Well, it's half of that, isn't it? That's going to be 16. Yeah. So we get 16 for the radius for the big one. And what's the height of the big one? 24. Yeah, so 16 and 24. Nice. The small one, what's the radius? Half of 18. It's going to be 9. And the height's 13.15. Okay, so that'll be 9. And that'll be 13.5. Okay, sorry if I'm rushing a wee bit. I've just had some technical difficulties, so it's been a bit longer to set up than I expected. I don't know if I've done wrong. I apologise if the cursor hasn't been great as well. I've tried to remember to use the mouse. It doesn't seem to want to respond to the pen for the cursor. I don't know what's happened there. But yeah, so loads of good examples I've already got online here. Have a look at them. And then I've just taught you through these two. So compound shapes, come up with a strategy, write down your equation for the two shapes, add them together. Okay, really straightforward. Sometimes there's a good 4 marks in these, and really it's actually just subbing into a very simple equation. Okay. Very last one. Yeah, let's go for that. So we'll just do B first because B is actually quite straightforward, I think. So Jim keeps his iron in a storage box, and he has the volume half, sorry, which is half the volume of the basket. Oh, actually, never mind, we'll start there. So there's the basket. Height is 50, and there's the cross section's got 2 semicircles. Yeah, okay. So we've basically got a cuboid, don't we? Yeah. Some fantastic technical drawing here. Ooh, look at that. So we've got a cuboid, and then we've kind of got this, sphere thing at the sides, don't we? That kind of thing. Yeah, going on. So find the volume of the basket and give it to 3 significant figures. Okay, so that's quite interesting because I think you would look at that and say, well, it's not a perfect sphere on the side actually. But I think, oh, actually, okay, yeah. So we aren't looking at a sphere. We're looking at more semicircles, aren't we? Yeah, okay. So okay. So before we've looked at like the example up here, that was more like a full sphere. This is kind of like a semicircle being dragged down. Okay. Well, the first thing I'm doing is say, well, we want to do the volume of the kind of cuboid in the middle. Call it cuboid, and then we'll do the volume of the circles. Yeah, so we keep that quite separate. Okay. So I want to do a kind of length times breadth times depth number for this. Okay. So we'll do length times breadth times depth. So what would that be then? I've got a length of 30, I've got a breadth of 24, and my depth is going to be 50. So I've got 30, 24, and 50. That's nice and straightforward. And for the circles, well, what is the area of a circle? Well, it's pi r squared for a full circle, yeah? And we've got 2 of them, so we'll just, instead of doing that divided by 2, then times by 2, we'll just do that for the 2 circles. Okay, so it's just pi r squared, yeah? So pi r squared, we need to times it by the depth as well, yeah? So it's the same depth as before, times them by 50. This time we've got to do pi r squared, where it's pi times half of 24, because 24 is diameter, so it's going to be 12 squared. Okay, so that should give you the start for that question. Okay, so volume of a cube, and then we've got these 2 circles. The mistake what would have made here is to maybe times it by 2 or not divide by 2 or something, So you could have technically done pi r squared divided by 2 and then times it by 2 at the end. You could have done that if you wanted, but I've just done one step together. Okay, again, it may be worth writing that down in an exam where you just say 2 semicircles equals 1 circle, something like that, just so the marker knows exactly what you're doing. Okay, so what was the answer to that one then? Just so I can go on to the next bit. So 58600. Okay, so that's your first one. So it says Jim keeps his iron in a storage box, which is a volume half of the basket. The storage box is shaped like a cuboid. Find the height. Okay. So now we're saying, look, we know the volume is 58600. I don't know if you have to use that volume or the other volume. I think you probably wouldn't get penalised either way, actually, as long as you were clear what you're using. But basically, we're saying the volume, yeah, is going to be equal to length times breadth times height. Yeah. So we know that the volume of the basket was 58,600, and he keeps his iron in a storage box, which is half that volume. Yeah. Which is a volume half of that of the basket. So, good England, mate. Good English. I would say the storage box is half the volume of the basket, so that's half the volume of the basket, yeah. And then we were saying the storage box is your cuboid. Find the height. Okay, so we know the length is 35, we know the breadth is 28, and then we're trying to find the height. Okay, so we just substitute in. So 58600 divided by 2, it's going to give us 29,300. I probably shouldn't do that in my head. And then 28 times 35, that's going to give us 980 H. So then what do? Yep, to move that over, we're timesing it on the right, so we're going to divide on the left. Yep, divided by 980, and that should give us our height. Okay, so 29300 divided by 980. So the height should be, just round that to 30. Doesn't say anything about rounding. Okay, so 30 centimeters. And that's you. Okay, so that last question I think is great. You know, it's making you think a little bit, different shapes, putting in a context which can be confusing for people. Okay, so yeah, I hope that's helpful. You're breaking up into its cuboid shape, and then it's kind of, that's not a sphere. That's the only thing that you could get confused with. You could use the sphere um, shape for that, but it looks like it's a circle that's then times by the height. Okay, rather than using the sphere. So you're using a cylinder. Sorry, yeah, it's a cylinder rather than a sphere. That's the only thing there. So yeah, compound shapes, adding them together, and then at the end there, it's like, what's the height of this box? Well, you've got to kind of think about what you're being asked. So I know that my volume is half of the original volume, so we'll divide that volume by 2. I know the volume is length times breadth times height, which is 35 times 28 times an unknown, and then you're rearranging. Okay, you could have done this divided by L divided by B and then substituted in if you wanted, but I think this is quite an easy way of doing it. Okay, let's just check if that's, yeah, 29.1 to 1 decimal place, yeah. So I hope that's helpful, and any questions, give me a shout, okay? But it's a really nice little bit of work there, actually. The wording on that's not very fair, I don't think. but yeah, that's a really good point of progression of that as well for you, just to kind of build up the thinking. You know, starting off with your areas, getting your volumes, and then getting into compound shapes, and then then a context. And like I said, if you want further working, you've got these in here already. Okay, thanks very much.